I think coffee break helped a lot. Hope people got taken care of your incidents which got paged. I could see a lot of people okay, in their laptops are busy. I could see that part. Okay. Okay, let me start. Skip the agenda. Okay. Let me introduce what exactly we do take care and as part of the SRE and the platform development team. So before I do explain, we'll just give a brief oversight on the whatever the VMware cloud products being provided. We have wide varieties on different cloud providers. So our topic majorly concentrates on the multi-cloud environment, how we are tackling the challenges around it. So this is a generic way of how the SaaS scaling is happening across the network, compute, and storage areas. I will not take much around it, but what exactly the change we brought in for the multi-cloud environment? There is a vertical scaling. Okay, so we need to address both the things: horizontal scaling of the SaaS services, vertical scaling of the infrastructure as a service part. Okay, so when we talk about the multi-cloud, we do support various providers. Okay, so I could not disclose all the providers, but okay, as per the NDA things, right? But we have wide providers. We are taking care of it. Okay, the overview. Okay, so we built an interface like an SPOG, single pane of glass, where it takes care of all the provisioning of the SREDCs. When I say SREDC, the VMware core products, that is vCenter server, which acts as a management tool for all the VMs, the NSX, the network migration customization part, as well as the ESX, the bare metal for the VMs. So I use the term the SREDC, which is used for the provisioning across all the providers part, provider 1, 2, 3, A, B, C kind of things. Okay, so this interface helps us in onboarding any of the SREDCs on various providers, as well as we do take care of the monitoring as well as instant handling part. Okay, so monitoring, what is the need? I think people are aware of what are the different monitoring steps we need to take care of, the instance, whatever being paged, handled, alerts, auto triaging, auto remediation, post-mortem analysis around the instance, what are being paged, triaged kind of things, why it is being paged, how we can avoid it, how we can mitigate kind of things, as well as the upgrade. One of the key aspect here, upgrades, because we talking about the SREDCs, there will be different flavors of SREDCs being deployed against the different customers' perspective on the different providers. Okay, so the combination for the upgrades working on different providers and different customers, the combination could be like M cross N cross O combinations. Okay, so this is where we need to ensure how we are managing, maintaining the scripts, automation scripts, okay, as well as deprecating, which are irrelevant stuffs. So once we keep moving on to the next versions, all these things, how we are maintaining the stack around it. So what is the need for maintaining it, why we need to maintain, and why we need to deprecate around it. So it is a combination of both script discoverability and script deprecation, both the things we need to take care. These are the two aspects around it. So I'm not touch basing what are the different architecture view of the SPOG which we built on to maintain and manage the multi-cloud infrastructure part. Okay, so who are the key consumers or owners for writing of the automation scripts? So all the service owners, all the component owners, everyone are part of these writing the automation scripts. Okay, so this platform enables them to build their own scripts, execute like a scheduled one or a fleet-wide executions with a scheduled or manual executions, all these things. Okay, so what is the need for the script deprecation? More insights Renisha will be covering, who is my colleague. Okay, so I'll just give the handover to Renisha. just before she comes in, yeah, you can join. So what exactly we are talking about the scaling aspect here. So these are a couple of stats which we have brought in. So you can see the current automation scripts which are closer to 2500, but running against the number of hosts is a good number of hosts whatever we are having, and the number of scripts being executed, the current quarter we could see it is reached the 15 million executions we are looking at, and we are anticipating at least a 20 plus million by end of Q4. So we need to address these executions at scale and also ensure, like all the scripts which are irrelevant enough, how we identify it automatically and how do we ensure they are deprecated if it is not useful enough, and how do we notify the same to the respective owners. Yeah.
Thank you, Bharat, for covering the overview of automation platform. So let me add some more points around this. So here you can see our automation guide. Okay, so there are multiple teams that contribute automations to our automation platform, and the end users or these automations are triggered from multiple users who are usually on call, or it need not just be the users, it can also be automation, say incident response, right? So there is an ongoing incident and there is an auto remediation set for that particular incident as an incident response based on the similar alerts that had come in over the time. And utilizing that information, we might have set some auto remediation. So this automation platform is responsible to execute these automations on the customer infrastructure. And it can be one SDDC or it can be n number of SDDCs. It can be one flavor of SDDC or it can be a different flavor of SDDC. So the automation platform supports these multi-cloud customer infrastructure, and it expects the automations also to work for a multi-cloud environment, right? And as Bharat told, this is a scale that we have. We have about 10,000 plus workloads that are running, and our automations are about 2,000 plus automations. And our executions are 15 million, reaching up to 15 million. That means that each of these executions are accounted for and are as a part of an incident response or as a part of an automation, may it be an upgrade process or anything, or may it be a troubleshooting process, anything at all, right? So when we are working at such a scale, it is very important for us as an automation platform for the automations to remain relevant. Okay. So when we talk about relevancy of automation, there are these various challenges that comes into picture that kind of defines what it means by automation to remain relevant. For us, these are some of the main items that challenges that we define for ourselves. Operator discoverability. So when I say operator discoverability, when SRE on call comes to the automation platform and they are trying to triage an issue or respond to an issue and they are looking for an automation, then they should be able to find the right automation on time, because we all know the MTTR ticks, right? So we have to resolve the incidents as soon as possible. So another challenge that we have is developer discoverability. Since, as Bharat said, we are allowing everybody to write automation and all the service owners are different, there are a lot of teams that are owning a piece of a code or piece of a service in the entire infrastructure that is deployed in customer for the customer. So when a developer has to write a new script, if they should be able to discover a reusable code block that might have been already written, or they should be able to find the similar automations that might have been already written and probably improve on those automations rather than writing a brand new one. And quality of automation is super important as we are working on a customer infrastructure day in, day out. And these automations are incident response, right? They shouldn't create a new incident for us. So it is very important for our automations to remain of utmost quality. Maintenance, when we are looking at such a scale, what if the automation platform breaks? Then what happens to the incident response? Of course, the MTTRs are impacted, SLAs are impacted, and the on-call is unable to resolve the issue on time. So maintenance of the entire automation platform is very important. Now, let me take an example, very specific example of a problem or a challenge that defines all of these challenges or give a perspective of these challenges. We call it script rot. Okay? So what is script rot? So this is he's an on-call person who gets paged like all of us when we are on call, right? So he looks at the run book. That's the first thing that we do whenever we get paged, okay, and we look at the steps. Now he finds a step in the run book which asks him to restart a service which is called, say, XYZ. He goes into the automation platform and looks at the automation options that is available for that to restart the service. He is able to find two different automations. One is named restart service XYZ, another named BKP restart service XYZ. Here, these automation scripts, what we have are Python scripts, but it can be very different for each of you. It can be an API, it can be a Jenkins job, or anything that is a part of an incident response, depending on the team or depending on the incidents that you have and depending on the incident response model that you have in place, right? So he has to choose between these two. Now, would he be able to make the right decision by the information that is available to him when he sees the script? Possibly not, right? He can execute either of them, and both of them seems like a best fit. Let's look deep into each of these scripts. What are they doing? The one logs into the system, executes a restart command. Another logs into the system, executes a backup command, and executes a restart command. Now, which is the most relevant automation? Again, it depends. There is no specific answer. If the version of the customer STDC is something that supports backup, then the second one. Otherwise, it is the first one, right? So it exactly depends on the time and incident itself, and it is not always set that this is the automation that is very relevant. Now, how we can identify which, or how can we make our automation platform help us identify which automation is reliant, which automation is relevant at the given point of time. So what if the on-call engineer had access to more information about, say, customer infrastructure, about the automation itself, about what versions of customer infrastructure does the automation support, and all of these things, right? That would be very helpful. But there are few challenges in doing that, and one of the way to do it is enrich these automations with all of these information and write a really nice documentation that this supports this version, it expires on this day, and this supports version after so and so, and all of these things. But how to maintain this? It is very difficult to keep these automations up to date over time, because the developer will have limited visibility into the scale that the system is going to go through, into the incidents that might come in as the newer version of infrastructure is available, right? So writing all of these, or kind of a hard coding all of these documentation into each of these automations might prove to be difficult. So, but of course, if we do that, we have the visibility into the automation. Another way is for someone to go and look into the system and delete these irrelevant automations. I already said that we have 2,000 plus automations. Looking into these 2,000 plus automations time to time is a huge operation toil for any of the teams. It actually goes against the principle of SRE itself. So this is not an option, and I guess none of us would be happy to do that, because when we have to delete something, instead we would spend that time to build something better, right? So yeah. So using data points to decide which is a relevant automation for us. So this is what worked for us. So what do? We gather data from various sources, like the version information for that automation or the infrastructure information. We correlate all of this data, build it into a nice visualizable reports, and feed that data back to our automations itself. Now, let's look into this process, or how did we actually achieve this? Okay, so we have this system implemented in production and has been running for almost 7 months now. So how do we do it? Let's go through each of these things on how actually we define the life cycle of our automation using the process of data collection and data aggregation and automation. So first thing we do is we collect the data. It can be different kinds of data, a static, dynamic data related to the automation and infrastructure. Aggregation and reporting, we report on all of the collected data. We correlate these data, like automations and the infrastructure and upgrades or lifecycle event or anything of that sort. Send that data back to the automation platform. This would be the curated data that is sent back to the automation system. Build automation on top of this data. Here, we are not using any kind of machine learning. It's simple SQL queries that are written to build the report, and the data is formulated and sent back. And then drive actionable outcomes. What are the actionable outcomes? Depends. It can be delete this automation since it is irrelevant. Look at this automation since it is not working in production for so and so long, over the time. And auto-suggesting automation as and when a user logs in. And all of these actionable outcomes are derived from this process. So what data do we collect? Some of these are very minute data, but very useful, and some of these are major data. One, the static data, who wrote the automation, not really very static, but does change, but not very frequently. So who wrote automation, when was it written, what are the files that were modified, what are the dependencies that are defined, and if there are any specifications that were there when the automation was created. Dynamic data, which is how frequently is this automation executed, what were the output, and if it failed, what was the failure reason, and what version of automation that got executed on what resource, and test data, integration test, pass or failure, and end-to-end test, because all of this data is very important to us, because it is the scale and the infra that we are working on is very different for each customers. So what reports do we build from all of this data? We report on success and failure rates of each of these automations, and most used, and we use that to show this metrics in the UI so that operator can make the right choice. And most used, least used. Least used are usually removed, and then contributors and users. So users are used for, users data is used for rate limiting or resource allocation and anything of that sort in terms of scaling. Contributors are pushed, we notify these contributors about the best practices to write the automations and anything that comes when we have to write a correct automation. The fourth one here I have defined as impact, dependencies, and relevancy. This is a derived matrix. This is not something that is readily available, but is built over time. So based on this data, we decide on impact of automation and whether it is whether it modifies the system and how frequently did it create issues, and is it safe, and all of these things. Dependencies, every automation, it is a possibility that each automation is dependent on a different automation. So what are these dependencies? Tracing of these dependencies, probably a API or a version of API or a library or anything of that sort. Relevancy, based on all of this data that we have collected and reported on, we built this relevancy data. How relevant is our automation? It is a derived matrix. The test analytics. So as we are saying that we are working on an infrastructure where each customer SDDC is different. So it is quite impossible to test automation on all possible features or all possible kinds of customer infrastructure that is available at the time of development or at the time, because these are sometimes band-aids. These automations are there for a very minimal time until the dev team fixes the issue. This is a workaround. So the automation developers do not have enough time to test it on each possible flavors. So this automated tests that run across the customer or across the fleet or test SDDCs are pushed back as a matrix and are utilized to build reports. Now, this is the design that we have in place. Here, the script, when the automation script enters the automation platform, all the static data that is related to its commit is consumed and in the data lake. And not just that, the data lake will have the data from various other sources. All of that data is correlated and passed down to the automation platform. Now, this automation platform processes all of this data and the reports that are built and derives these metrics that are visible in the UI when an operator has to choose the automation. So it solves all the challenges that we already discussed. So and also it derives some of these notifications, like if at all the automation platform finds an irrelevant script because it was not used since a year or so, because it frequently failed in the customer SDDC because it was irrelevant or for various other reasons like version or anything of that sort, it will send notification to the contributors and the script owners. They have to make a choice whether they have to keep these automations or not. And if they have to, they have to modify the automation, or they have to tag that this is something that we need, keep it, even if it is not going to be used for a very long time. So if nobody responds, the automations are automatically deleted. So yeah, so now with this entire process in place, what we have achieved, we have solved the problem of operator discoverability by auto-suggesting the automation at the right time. We are helping our on-call engineers to make informed decisions based on all the data that is available to them, and this is done automatically. The metrics are available for the on-call engineers and for the management to look at and make the right choices in terms of automation. We are also solving the developer discoverability by building a feedback loop so as we are collecting all of this data like integration tests and commits and including the commit messages, files, and all of this data, it builds a feedback loop through which we can notify the developer on how to improve their automations and better. Traceability, they are able to search the dependencies automatically without actually looking at various multiple code bases or looking at the infrastructure in itself in deep. It helps us maintain the quality of automation by giving access to the metrics, and which in turns it leads to a stable automation. Say for some automation a commit has gone in, right, and it has not been passing the some sets of integration tests or end-to-end tests, then these automations are paused in production so that nobody can execute it, nobody can use it, which makes the quality of automations and automation platform itself better. And it helps us maintain the automation platform. As we reduce the number of automations, it means our APIs need not pull 2,000 or 3,000 rows every time whenever a user logs in, and we don't have to look at each and every failure one by one, because the system already does that for us, right? So it helps us maintain our automation platform. And dead code removal, so the tech debt that always sits in the backlog and moves to the next sprint and the next quarter and the next year, it is all of that kind of challenges are resolved here automatically. So, but no system is perfect. We do have some limitations. For this system to work, we need to have a very stable, fail-proof data pipelines. If at all we miss even a single day's data, the derived metrics can be different. So we have to make sure that pipelines are stable and are not failing, and we have to alert on these pipeline failures or data push failures, and the visualization or report failures and all of these related items. And storing the telemetry data, since we are storing a lot of data, it is pretty costly, and we need data for a longer time. Like we cannot work with the 30 days data or 60 days data. We need data for at least 6 months. So yeah, that leads to the fourth point. Amount of data that is available is very important to make the right decisions. And we need to have the right visualization capabilities as well. Unless we are able to put the data into charts and graphs, it is very difficult to take decisions. They are just rows and columns of data, right? So unless we have a really good bar chart or line chart or heat map or anything of that sort, we cannot really think of a way of automating and bringing the lines down or the bar down or anything of that sort. So it is very important to have a really good tool with which we can build reports on these aggregated data that connects to a data lake. And yeah, so these are few of the limitations. But what do we learn from all of these? So it is very important to track and maintain that the automations are relevant, else it will break, it might end up breaking the customer infrastructure. And feedback loop to the automation is also very important, because when we are starting an automation platform, we may not really think about gathering all of these data and building these data pipelines and all, but when we have to scale or scale fast, it is very important to have this initial data pipelines in place so that we can utilize this data to work for us. So that's why it is data-driven decisions are much better than deciding on something by ourselves or manually. So yeah, that's all I had, and this is kind of a part 2 of something that we had presented in SREcon19. So this 2019 was when we started building the automation platform. Version V1 was available then, and we had given a kind of a roadmap for ourselves in this presentation then. And now we are looking at the same automation platform after 4 years, and we have achieved everything and more that was written in that roadmap. So yeah, that's all I had.